Hello everyone, and welcome to Module 6 of our meta-analysis course. In this module, we'll be discussing a couple of different ways in which you can do meta-analytic reviews. Alright, so as I've previously alluded to when going over the history of meta-analysis, there are two main traditions in which we can do meta-analysis. The first is the Hedges and Olkin tradition, and you'll notice here that this includes a citation to the Bornstein et al. Textbook, which we're using for our course. You'll also notice that the second tradition is the Hunter and Schmidt tradition, of course, which is also another recommended reading for this course, and we can refer to this one as psychometric meta-analysis. So here's a table that just shows you an overall a bird's eye view of the differences between the two different types of meta-analytic camps. So we've got the Hedges and Olkin on the left side and the psychometric Hunter and Schmidt approach on the other side. And there are certainly some other approaches to doing meta-analysis which overlap with these two, but these two camps would be are what considered to be the two primary approaches. So as far as the Hedges and Olkin tradition, certainly this is the type that I think is more widespread across different scientific disciplines. Within my own area of management, we see this psychometric approach. So this is industrial organizational psychology, organizational behavior, and also in other areas within general psychology. There are other differences related to the statistical underpinnings, the recognition of statistical artifacts, and then the use of significance testing, which is something that we'll be discussing in a couple of slides. Okay, so when we're looking at these two different approaches of meta-analysis, they are both out to identify what the population mean is. When Hedges and Olkin users refer to the population mean, they're defining the population mean as some average of the observed effect sizes, so what we can actually see. Compared to the psychometric approach, those who use the Hunter and Schmidt tradition define the population mean as some average of the observed effect size that has been corrected for statistical artifacts such as measurement error in the variables and the possibility for range restriction or range enhancement. We're going to spend a little bit of time in Module 7 discussing about the need to correct for measurement error, and this is something that I'll recommend that you all do in your meta-analyses. It is possible to make corrections for artifactual variance, such as measurement error in the Hedges and Olkin tradition, but this is something that's not particularly common. Okay, so some other details. The Hedges and Olkin meta-analysis is an analysis of effect sizes, again, at the indicator level. So they look at what is observed, and they would refer to this as a non-biased estimate of the population parameter. Unfortunately, or differently, psychometric meta-analysis looks at the observed effect sizes at its latent level. So the observed effect size is judged to be a biased estimate of the population effect size that has to be corrected for measurement error. And potentially for other types of artifactual variance. And this usually results in increasing the magnitude of the effect size because measurement error will always result in underestimating the effect size. Okay, so both camps, of course, want to understand what causes variance across studies and magnitude of effect sizes, and both camps do in fact recognize that variance across studies may be a function of statistical noise, such as random sampling error, as we discussed in Module 5, but also systematic sources of moderating variables. Both camps would recognize that random sampling error is one type of non-systematic statistical noise. Both camps would recognize one class of systematic variance to be moderators. However, we go further with the psychometric meta-analysis approach and say that observed effects may differ across studies due to differences across studies in measurement error and range restriction or range enhancement. So this and the psychometric approach would be another source of systematic variance. So this is, I think, a nice illustration to summarize what I've just said. We have here variance, and there's obviously multiple sources of variance. We have the sampling error, which is accounted for in the Hedges and Olkin tradition and in the Hunter and Schmidt approach. We have concerns about moderating variables, so this would be something that, again, in both camps you'd want to consider. However, what is unique to the psychometric approach is the artifactual variance that is an additional source of variance. And this is, of course, noise that we want to remove, and we do this by correcting for things such as measurement error, which, as I said before, we'll discuss in Module 7. Okay, so there are two generic models also. I think this is one final point that I'd like to make. Two generic models that we could use when actually calculating statistically a meta-analytic review, and we can use what is known as a random or fixed effect meta-analysis. When we're looking at meta-analysis in the Hedges and Olkin tradition, we can use both a fixed or random effects meta-analysis. So when I'm talking about a fixed effects context, we would be assuming that there's no variance in the population whatsoever. So you can imagine that in medical research, this might be something that they might use where they're assuming that there are that the population that they're drawing from is all one homogeneous population. Compared to other areas like in the social sciences where we do not make such an assumption. So due to the assumptions underlying both estimation models, we would typically say that the random effects model is the generally more accepted approach. So in this instance, the amount of error in the parameter estimates computed by the fixed effects meta-analytic model would be underestimated when there's actually true variance between studies. And of course, this is whenever it's greater than 0, which in our areas would be, most areas in the social sciences would be all the time. All right, so that's a very brief overview of two camps of meta-analysis, and we'll proceed in Module 7 to discuss actually correcting for types of artifactual variance.